Chapter 4.8, question number 49. Two particles move in the xy plane. At time t, the position of particle A is given by x of t equals 4t minus 4, and y of t equals 2t minus some variable k. And the position of particle B is given by x of t equals 3t, and y of t equals t squared minus 2t minus 1. So part A, if k equals 5, do the particles ever collide? So for the particles to collide, we know they have to have the same x position and y position at a given time, or for a given t value. So let's start by setting these two equations equal to each other and seeing what our t value is. So for the x's, if we have 4t minus 4 is equal to 3t, we can subtract 3t from both sides and we get t minus 4 equals 0, or t is equal to 4. So in other words, this tells us that when t is equal to 4, the x position of particle A is going to equal the x position of particle B. So now let's try the same thing with the y variables. We get 2t minus 5, because k equals 5 here, equals t squared minus 2t minus 1. Add 5 to both sides, subtract 2t, we get 0 is equal to t squared minus 4t plus 4. So this will factor to t minus 2 times t minus 2 equals 0, meaning that when t is equal to 2, the y position of particle A will equal the y position of particle B. So because these t's are different, we know that for a given t value, both the x position and the y position of particle B will not be the same. Therefore, no, these particles will not collide. Okay, part B. Find k so that the two particles do collide. So we know k only affects the y variable of particle A, so we know the x equations are going to stay the same. And we know that when t is equal to 4, the two x equations will equal each other. So we know that for part B, t is going to equal to 4, because then we don't have to touch the the x variables. So we're wondering that for 2t minus k, when is that equal to t squared minus 2t minus 1 when t is equal to 4? So let's just start by plugging in t, and we get 8 minus k is equal to 16 minus 8 minus 1. Or 8 minus k is equal to 7. Subtract 7 from both sides, add k, and we get k is equal to 1. So when k is equal to 1, the particles will collide at t equals 4. Part C. At the time the particles collide in part B, which particle is moving faster? So we have to remember the time is equal to 4. And that the equation for instantaneous speed can be written as speed is equal to the square root of dx dt squared plus dy dt squared. So let's start with particle A. Speed sub A is going to equal the square root of dx dt squared. So let's go back up to the x equation, 4t minus 4. The derivative of 4t minus 4 is simply 4. So that'll be 4 squared plus dy dt squared. So the derivative of 2t minus k, the k, since it's just a constant, will become 0, and the derivative will become 2 squared. So this will equal the square root of 16 plus 4, or the square root of 20. So now let's do B and compare the results. Speed sub B is going to equal the square root of dx dt squared. So the x equation for particle B is just 3t, so the derivative of 3t is just 3 squared plus dy dt. So this one's a little trickier. Y prime t in this case is going to equal 2t minus 2. We have to remember that t equals 4 here, so we have to plug that in. And we get this is equal to 8 minus 2, which is equal to 6. So dy dt for particle B is 6 squared, which is equal to the square root of 9 plus 36, which is equal to, the square root of 45. And we know that the square root of 45 is going to be greater than the square root of 20. Therefore, particle B is moving faster. And we're done.